Yeah, what we're going to do is we're going to actually take a look at the problems we were doing in the hallway. So what I'm going to do is kind of walk through each one of them, and I will show you the process. I'll probably do them about 2 or 3 at a time, so these videos aren't excessively long. So we're going to go ahead and start with the first one that you had in the hallway. The first one you had in the hallway said, the radius of a sphere is increasing at a rate of 3 centimeters per minute. At the instant that the radius of the sphere is 5 centimeters, what is the rate of change in square centimeters of the surface area of the sphere? Recall that the surface area of the sphere is surface area equals 4 pi r squared. So we're going to go ahead and share the screen so we can take a look at this. So here is our problem. Our problem, again, talks about the sphere. Here's our idea of a sphere. It says it's increasing at a rate. The radius is increasing at a rate. So what it means is when I say radius is increasing at a rate, that is basically telling me a derivative, a implicit. So that tells me that dr dt is going to equal positive 3 centimeters per minute. That's what it's saying, positive 3 centimeters per minute. At the instant that the radius of the sphere is 5 centimeters, so it's going to tell me the radius is 5 centimeters. What is the rate and change of square centimeters of the surface area? So it's asking me, hey, what is ds dt? So now what we're going to do is we're going to use the formula down here with the information we have. So I kind of transfer it. I know for the first one, again, that my surface area is equal to 4 pi r squared. We don't substitute until after we do the implicit differentiation. So we're going to do the derivative of the left, which is ds dt equals 8 pi r dr dt. Power roll 2 times 4 is 8 pi r dr dt. And now what I know from the sheet is that dr dt is equal to positive 3. And I know that radius is equal to 5 centimeters. So I plug in and I get ds dt equals 8 pi times the radius 5 times 3. And realistically, if I wanted to, I could say that the answer was centimeters squared per minute. 8 pi times 5 times 3 radius squared per minute. And
How long did you let them work?
okay, sorry about that. Had a visitor stop by. So okay, back to where we were. So what we had done is we had substituted in, again, in the world of FRQs, this would be a sufficient answer for an FRQ. I just leave it like that. But if we really wanted to multiply it out, 8 times 5 is 40, 40 times 3 is 120. So that tells me that ds dt is going to be 120 pi cubic centimeters per minute. And again, the thing to think about it, it's positive because it said it's increasing. Sphere is getting bigger, so that means the surface area is getting bigger. So that's our answer to our first one. Our first one is that. Okay, so now we're going to move to number 2. Number 2, the radius of a circle is decreasing at a rate of 0.3 meters per minute. What is the rate of decrease in the area of the circle at the instant that the circumference is 10 pi meters? So again, we're going to read this stuff, decreasing at a rate. Or the moment you see the word rate, it's telling you a derivative. So it's saying the radius is decreasing. That is telling me that dr dt is going to be negative 0.3 meters per minute. What is the rate of decrease in the area? So it's asking me, hey, what is dA dt? I don't know that. When, and here's the trick, it says circumference is 10 pi meters. Well, here comes the problem. The formula I'm going to use is area equals pi r squared. Circumference doesn't help me immediately with that. However, if you remember the formula for circumference, circumference is equal to 2 pi r. 2 pi r is equal to 10 pi. Divide both sides by 2 pi. And indirectly, I find out that the radius is going to be 5 meters. So what I'm trying to do is I'm actually trying to figure out dA dt when the radius is 5 meters. Okay, so now what I'm going to do is I'm going to bring it over here to do the formula. I have area equals pi r squared. So that tells me that dA dt is equal to 2 pi r dr dt. But according to the problem, I know that the radius is going to be 5 meters. And I know that dr dt is going to be equal to negative 0.3 meters per minute. So I can plug in to figure out the dA dt. is equal to 2 pi times 5 times negative 0.3. And then again, FRQ world, we would just want to go ahead and stick it down here that this would be meters squared per minute if we were doing it in an FRQ, and that would be fine. But in the world we're in right now, if we want to simplify it, this is again a non-calculator thing. 2 times 5 is 10. 10 times negative 0.3 is going to be negative 3 pi meters squared per minute. So that tells me I'd go and look for my negative 3 pi squared. Now here's the thing I want to be aware of. This actually happens in these problems, that when we go to look at this answer, we're going to find out is that the answer here says 3 pi meters squared per minute. So it takes us to slide 8. The reason there's a difference, we see negative 3 pi, but the answer here is 3 pi, is the following. I want to show you. It says rate of decrease. Okay, so here's what I need you to understand. This is one way to represent this answer, or the other thing you could say is it is decreasing at a rate of 3 pi meters squared per minute. Because I say the word decreasing, it implies the negative. The thing to be careful about is don't put the negative in front of it. Because if you're saying you're decreasing at a negative rate, you're technically increasing. Okay, so that's 2. I'm going to do number 3, and then I'll see how the timing is going on number 3 for video for timing's sake. This is a little tricky. This is more of a thought exercise, I guess. If the base of a triangle is decreasing at a rate of 2 inches per minute, if the base of a triangle, so that's telling me the derivative of the base with respect to t, it's decreasing, so negative 2 inches per minute. Okay, so per minute, make sure you see that's like a fraction. While its height is increasing at a rate of 1 inch per minute. What is the relationship between the base and the height when the area is increasing? So area equals 1/2 base times height. So I have some stuff here, and notice I don't have an actual value of b, I don't have an actual value of h. I'm actually going to have an expression in this problem. It's a little different. So what I'm going to have is for number 3, I have area equals 1/2 base times height. And what I'm going to do is I'm going to implicitly do a derivative, implicit differentiation, dA dt equals. Now here comes the deal. I got to do the product rule because this is multiplication of a product. So what I'm going to say is u equals 1/2 b, v equals h. So u prime is going to be 1/2 dB dt, and v prime is going to be dH dt. So when I take the derivative, it's uv prime plus u prime v. So that's going to be u, which is 1/2 b, times was it v prime, which is dH dt, plus u prime is going to be 1/2, and we're going to deal with 1/2 dB dt, times v, which is h, so 1/2 h dB dt. And now what I'm going to do is substitute in the values. So hang on 1 sec. So I'm going to substitute in the values of dB dt and dH dt. dB dt was -2. So that tells me it is 1/2 b times dH dt, and dH dt from the problem, dH dt was +1, dB dt was -2. So that's 1/2 b times 1, and we're going to have 1/2 h times -2. 1/2 times -2, this is going to be minus h. So that's dA dt. And the question asks me the following. What is the relationship when the area is increasing? So if the rate of the area is increasing, that is saying dA dt has to be greater than 0. That means this means we have an increasing area. Well, I know that this expression is the same as this, so 1/2 base minus height has to be greater than 0. And what I'm just gonna do is add h to both sides. 1/2 b is greater than h. So this is gonna have an increase. Oh, I know I've been sharing. That's a problem. Okay, so what I did is I substituted in here. I substituted in for dh dt as a 1 and a db dt as a -2. And what it said is dA dt has to be increasing. So that means dA dt has to be a positive number. 1/2 b minus h has to be greater than 0. Add h to both sides. So this is a scenario where I have a function that is going to be increasing. It'll be increasing if half the base is greater than the height. Okay, so that is our next one. Our next one is going to be 7, and I'll do that in the next video because it's a little bit longer explanation. So what we're going to do is we're going to go ahead and stop this recording, and we're going to do a different version.